I'm Algebra Annie, and I'm here to help you be successful in your algebra class. No one is perfect. That's why pencils have erasers. Wolfgang Reeb. Our learning targets today are: I can solve one-step equations in one variable by using addition and subtraction.
So before we start the next lesson, I want to review something with you real quick. If I had 3 plus signs, this would be the same as having a positive 3 as a number. How would I want to zero this out from chapter 1? If I wanted these to disappear, what symbols would I need to put down here for them to zero out? If I had a positive and I put a negative with it, I know that these would zero out. If I had a positive and I put a negative with it, I know they would zero out. If I had a positive and put a negative, I know they would zero out. I started with 3 positives and then I put 3 negatives there. And when 3 positives were combined with 3 negatives, I know that my number zeroed out. We're going to use this concept in our next chapter. So our next lesson talks about solving equations. And our directions tell us to solve the equation. So here I have a picture representation of our equation. So you always need to think of our equations as though they are on seesaws, and the seesaw needs to be balanced. This seesaw is currently balanced. On this side, we have a box with an unknown value with 3 positive numbers, so something plus 3. On this side, we have a positive 5. These are balanced because both sides of the equations are the same value. However, we don't know what this secret box is holding. We need to figure that out. So we need to take things away or add things to our seesaw to see if we can get this box by itself. So I have a box equaling a value. So if I want this box by itself, I had 3 positive signs. What do I need to do to these 3 positives to make them go away and leave the box all by itself? So if I have 3 positives, I know that I'm going to put 3 minus signs on there because every positive will get combined with a negative and they will zero out. Well, right now, my seesaw just got crooked. If I put things over here, I need to put things on this side too. So if that was 3 negatives over here, here are my 3 negatives on the other side. For every positive you see, a negative can be disappeared. So this positive goes with that negative, they go away. Positive goes with the negative, they go away. Positive paired with the negative, they go away. Got to do it on this side as well. Positive, negative, they go away. Positive, negative, they go away. Positive, negative, they go away. On the left side of my seesaw, all my positives zeroed out with my negatives. So on the left side of my seesaw, what do I have left over here? I have just my unknown box value. And what was left over on this side? The only numbers that I see are these left over. So what's left over? 1, 2. So my unknown box value was a positive 2. So my unknown box value, I just discovered that it equals a positive 2. Now we're going to solve this same exact problem using a math equation instead of visuals. So here we're going to solve the equation going through our visuals again, and how would you represent that mathematically? So we had an unknown value plus 3, unknown value plus 3, and our seesaw has to be balanced. So our equation has to be balanced. Equals 5. Equals 5. So what did we do to our seesaw when we were trying to solve it the first time? The first thing we did was that we put down 3 negative signs on each side because we had to keep the seesaw balanced. It couldn't sway one way or the other. How do we visually represent that here? We put 3 negative signs on each side, and our equation needs to remain balanced. What did we do over here? We then started pairing up all of our positives and negatives. So this positive paired up with that negative and it disappeared. It zeroed out. This positive went with that negative. He zeroed out. Positive with a negative zeroed out. My left side is now zeroed out. Positive with a negative, positive with a negative, positive with a negative. So over here, what were we left with on our seesaw? The left side, we were left with an unknown value. On the right side of the seesaw, this is what we had left over. 1, 2. How does that happen mathematically? So mathematically, we did not do anything to our unknown value, so we still have our unknown value. We had a positive 3, and we put down a negative 3. We know that positive 3 and negative 3, these turn to 0. They zero out. We don't have anything left to write. It needs to remain balanced. So here's our balance sign. If I had 5 and I took away 3, I am now left with 2. My unknown value is balanced and it equals 2. So x equals 2. So this is our next problem. Our equation is balanced. What is on the left side of ours? We have an unknown value. So I have an unknown value. And he's with 10 negatives. So he is on that side with 10 negatives. My seesaw is balanced, which means my equation is balanced. On the right side, I have 4 positives. So on the right side, I have 4 positives. I want to get the unknown value by itself. So how do I make these zero out? Unknown value needs to be by itself. I need to make these negative 10 zero out. The way to make a negative 10 go away, zero out, is to put 10 positives with it. So we're going to put 10 positives. Right now, my seesaw is no longer balanced. It's too heavy on the left side because I only put them on one. You need to put it on both sides. So to help visually keep my seesaw separate so things don't start crashing. Same here. So things don't start crashing. I need to put that I'm adding 10 to the right. So here's my new 10. So I have added 10 more to both sides of my seesaw. So now I need to see what zeros out. So over here on my seesaw, this negative is 0 with a positive, 0 with negative with a positive. On the left side of my seesaw, all my positives zeroed out with all of my negatives. The right side of the seesaw, nothing zeroes out because there are no negatives to pair with these positives. So on my seesaw, what am I left over with? On the right side, all I have is my unknown value. There's nothing else on the left. What is on my right? All of this is still on my right. How many is that? That is 14 if you're to count it. So my unknown value is 14. How does that work mathematically over here? I have not done anything to my unknown value. He is still my unknown value. I had negative 10. I put positive 10 with it, hoping these would zero out so that I was left with my unknown by itself. Does a negative 10 plus 10 turn to 0? It does. These zero out. So my unknown value is left all by itself on his side of the seesaw. Remember, we put this little river here to keep our seesaw balanced and separate so we know what side is which. This is 4 plus 10. 4 plus 10 is 14. We had our unknown value being equally balanced and the right side said it was 14. So our unknown value is 14. So our final answer is x equals 14. Now we're going to continue to solve some example problems, but we're not going to draw the seesaw anymore. If you want to draw the seesaw, you may. I'm not going to. We're just going to start working with it mathematically. So I have an unknown value, x, and he is on his side of the seesaw with a positive 7. I wanted my unknown value of x to be the only thing on this side of my seesaw. So my positive 7 needs to disappear. The only way to make a positive 7 disappear is to put 7 negatives on his side of the seesaw. But our seesaw needs to be balanced. So if this is negative 7, you need to have negative 7 on the other side of the seesaw as well. My seesaw needs to remain balanced. I didn't do anything with my unknown value. My unknown value is still x. I had a positive 7. Then I subtracted 7. These zeroed out. I am now left with 9 minus 7 is 2. So my answer is x equals 2. Now over here on the side, I'm going to have you kind of check your work. You are telling me that I had an unknown value of x, and when I added 7 to it, I ended up getting 9. What are you telling me my unknown value of x is? You are telling me that it's 2. So if you're telling me that x was 2, if I continue to follow the equation and I was supposed to add 7, you're telling me that my seesaw said that that was 9. You need to prove to me that both sides of my seesaw are balanced. So here's my seesaw. Prove my left side of the seesaw is balanced with the right side of my seesaw. So on the left side of my seesaw, what is 2 plus 7? 2 plus 7 is 9. My seesaw should be balanced. What was the right side of my seesaw? It was 9. Is my seesaw balanced? It is. 9 does equal 9. So it is balanced, which means I did get my answer correct. Our next practice problem. I have negative 8 on the same exact side of my seesaw with the unknown value b. If you need to do your seesaw line so you keep it balanced and separate, you can. So negative 8 is with my unknown value. This side of the seesaw needs to be balanced with the number 2. So I have negative 8 and I need to add some value to get 2. I need my unknown to be by himself. My b needs to be alone, which means somehow I need to zero out this negative 8. How do you make 8 negatives disappear? So visually, I have 8 negatives. How do you make these 8 negatives disappear? You would put them with 8 positives. So you would put them with 8 positives. My seesaw is no longer balanced. You did not do the same thing to both sides. I'm going crooked. If he is plus 8, he also needs to have a plus 8 on his side. So if I had a negative 8 and I added 8, these turn to 0. They zero out on my calculator. I'm left with my positive unknown value of b. He is now equaling positive 2 plus 8 is 10. So you are telling me that b equals 10. You need to be able to check your work. So over here, let's check our work. The problem was negative 8 plus b equals 2. You told me that b was 10. So instead of b, I'm going to write 10. The rest of the equation is still the same. You need to keep it balanced. You need to prove the left side of the equation, or your seesaw, is the exact same as the right side of your equation, or your seesaw. If I have negative 8 and I add 10 to it, I get 2. So the left side of my seesaw is 2 equals the right side of my seesaw was always 2. Does 2 balance out 2? It does, which means your answer is correct. So here's our new equation. We have 2/5 equaling an unknown value of m minus 1/5. Yes, we have fractions. You treat this exactly the same way as you did any of your other problems. So first, I'm going to draw my seesaw down here so I know my left side has to be balanced with my right side. The concept's the same. I need my unknown value to be by itself. The unknown value is on his side of the seesaw with a minus 1/5. Or a negative 1/5. How do I make a negative 1/5 disappear? Zero out. I put it with a positive 1/5, and if I put it on one side of the seesaw, I actually have to do it to the other side of the seesaw so that I keep my equation completely balanced. I keep my seesaw balanced. So working with the left side first, I had 2/5 and I added one more fifth to it. I ended up having a total of 3/5. My seesaw needs to be equal and balanced. I had an unknown value. I did not do anything to my unknown value yet, so he stays there. Negative 1/5 plus 1/5 zeroes out. There's nothing left. My unknown value is by himself on that side of the seesaw, and so I have 3/5 is going to be my unknown value. So m, my unknown value, equals 3/5. You can write it both ways. Now let's go over here and let's check our work to make sure we're doing this correctly. The problem was 2/5 equals m minus 1/5. You are telling me that m is 3/5. So I'm going to write the entire equation exactly as it was, making sure everything is balanced. But instead of m, I wrote 3/5. Here is my equation balance line, so I make sure it's balanced. I didn't do anything to the left side of my equation. It is still 2/5. You're proving this side is balanced with this side. If I had 3/5 and I took away 1/5, I am left with 2/5. My seesaw is balanced. 2/5 is the same as 2/5, which means my answer over here is correct. So our new problem is negative 2.3 plus m equals 7. I want to keep my equation and my seesaw balanced, so there's my balanced line so we remember. I want my unknown value, which is m, to be by himself on his side of the seesaw, which means this negative 2.3 needs to zero out. It needs to go away. How do you make a negative 2.3 go away? So I am going to add 2.3 to both sides so that my equation is balanced. If I did it to the left side of the seesaw, I need to do it to the right side of the seesaw. Negative 2.3 plus 2.3 zeroes out. They have nothing left. This was left with a positive m, so there's my positive m. My seesaw is equal and balanced, so there's equal and balanced. I had a positive 7, and now I'm adding 2.3. 7 plus 2.3 is 9.3. My unknown value m is on his own side of the equal sign. He is supposed to equal 9.3. So right here we added 2.3 to both sides. This is called the addition property of equality. You can add the same number to both sides of the equation and the statement will still remain true. So when you're adding, it's the addition property of equality. Our last equation, d plus 1/2 equals 1. Here's my balanced seesaw line to make sure I keep my left separate from my right and to remind me that I need to keep my seesaw balanced. I had an unknown value d. He's on his side of the seesaw with a positive 1/2. I need to make that positive 1/2 disappear, zero out. How do you make a positive 1/2 zero out? You put a negative 1/2 with it. If you have it on the left, it needs to be on the right because you need to keep your seesaw balanced. I didn't do anything with my unknown value. My unknown value is still D. If I had a positive half and I put him with a negative half, they zero out. They eliminate. They go away. He's not there anymore. Here's my balance line to remind me that my equation needs to be balanced. A positive 1 minus 1/2 is a positive 1/2. So my unknown value D is equal to 1/2. D equals 1/2. Now right here to solve the equation, we ended up subtracting 1/2. We subtracted it from both sides. This is called the subtraction property of equality. You can subtract the same number from both sides of the equation and the statement will still hold true. When you're subtracting is the subtraction property of equality.
What did we learn today? I can solve one-step equations in one variable by using addition or subtraction. And I look forward to seeing you tomorrow in class.